Yeah, good day everyone. My name is Mr. Duro, a regular host on Practical Physics. In today's class, we are looking at the verification of Ohm's law, which states that provided the temperature and other physical conditions are kept constant, the current flowing through a conductor is directly proportional to the potential difference across the portion of the conductor. So, to verify this law, we are going to use basically three apparatus: the resistor box, as you can see, the voltmeter, the battery, and the switch. We might not need the ammeter in this case. Though there are other experiments that the ammeter might be incorporated into this. But before I proceed, this circuit has already been connected. The voltmeter, like I told you in the previous class, is connected in parallel to the circuit and it has been connected accordingly. Now, most of the times when you're about to verify this kind of experiment law, the question we ask you to determine the current when all the keys are plugged into the resistance box or when the resistance is 0. Now, the reading here states 1.3 volts. So, when resistance is 0, the value of the voltmeter is 1.30 volts. So, that is taken. Now, let's proceed. You might be asked to remove 1, 2, 3, 4, 5 in succession, or 2, 4, 6, 8, and 10 in succession. But for the purpose of this class, we are going to remove 1 ohm, 2 ohm, 3 ohms, 4 ohms, and 5 ohms in succession. And that is how we determine the voltage across the resistance box as we remove those resistance. So take note, when R0 is 0, the reading of the voltmeter, like I said, is 1.30 volts. So I'm going to remove 1 ohm resistance on this, and of course there's going to be an increase. I have here 1.32 volts. 1.32 volts when the resistance is 1. So I'm going to plug this in back carefully. Alright, and then remove the 2 ohm resistance. Like I said, before you carry out any of this experiment, make sure that all the values are well plugged in. Ensure that all the values are well what? Plugged in. The problem already. I made a mistake. It was an intentional mistake. And it's one of those things that you do when you are performing an experiment on electricity. I intentionally did not check this plug before I started with the readings, which is very wrong. And imagine I was doing the wire practicals, I would have made very silly mistake that will affect my table, will affect my graph, and automatically affect my entire readings or mark for the practical. So I have to start all over again. When R is 0, I'll ensure that all these keys are well plugged in, so I'm good. So when R0 is 0, the reading I have there is 0.40 volts. That's taken. So when resistance is 1, the reading is 0.50 volts. When the resistance is 2, the reading is 0.60 volts. When the resistance is 3, that is the combination of 1 and 2, give me 3. The value is 1. The value is 1.70 volts. And I'm going for 4 ohms, which is 2 and 2. Ensure the first one is well plugged in before you proceed. And that gave me 0.80 volts. So I'm going for the last one, which is 5 ohms. I'll just take this last one, and that's 1, 2, 2, making 5. And I have a 0.85 volts. So that is all about the verification of Ohm's law. Now what I'm going to do next is I'm going to tabulate my readings on the table, plot the graph, and determine the slope of the graph. Of course, that is going to be your assignment for today. And also on the same graph, determine the intercept on the y-axis. The intercept on the y-axis should correspond with the value of the voltmeter when the resistance is 0. If it doesn't correspond, maybe you might be slightly, below or above the precision value, which is not too bad, which is not unexpected when you're performing an experiment. So don't be discouraged, but make sure you note where the intercept actually cuts on the y-axis. And I'm not taking any readings. Like I always tell you, one of the precautions is to make sure that this key is removed when readings are not taken. This is to conserve the life of the battery and also ensure that you obtain a very good readings from your computer. Another thing is basically another precaution for the experiment, like I told you in the previous slide, is to ensure that all these connections are tight. These plugs are well plugged in when readings are not taken. And these connections are every terminals is tight, and the plug key for the switch is removed when readings are not taken. So I expect your assignment to be submitted right on this platform, or you can chat me up on my WhatsApp with your response. Many thanks for listening, and have a wonderful rest of the day. Bye-bye.